In a wide expanse of space, gravity drew dust and gas together to create the young solar system. The sun formed first from the vast material, with the planets close behind. But how did a sea of swirling particles become the brightest star in our sky? The sun is terrifying and gorgeous, and it's also the best physics laboratory in our solar system. Although it may look empty, space is filled with gas and dust. Most of the material was hydrogen and helium, but some of it was made up of leftover remnants from the violent deaths of stars. About 4.5 billion years ago, waves of energy traveling through space pressed clouds of such particles closer together, and gravity caused them to collapse in on themselves and then start to spin, the first steps of how the solar system formed. The spin caused the cloud to flatten into a disk like a pancake. In the center, the material clumped together to form a protostar that would eventually become the sun. There is a rotationally supported disk around this protostar. It's a key element in building planets. It lets the material hang out long enough for the planet formation process. The young protostar was a ball of hydrogen and helium not yet powered by fusion. Over tens of millions of years, the temperature and pressure of the material inside increased, jump-starting the fusion of hydrogen that drives the sun today. A star the size of our sun requires about 50 million years to mature from the beginning of the collapse to adulthood, according to NASA. Our sun will stay in this mature phase for approximately 10 billion years. The formation of the sun didn't take up all of the cloud it was born from. What was left continued to orbit the star, while planets formed from the leftover material. The sun is an average-sized star, not too big and not too small. Its size makes it an excellent star to orbit, as it is neither large and fast-burning nor small and dim. Several billion years from now, the hydrogen inside of the sun will run out, and the star will swell up into a red giant with a radius extending to Earth's orbit. The helium at its core will also be consumed. The star will never be hot enough to burn the oxygen and carbon that are left behind, so the sun will fizzle out and become a white dwarf.